Hi, good afternoon, good morning, good evening. Rob Gauthier. I'm going to cover about getting started with our UMA and just give you a little bit more detail on that. So UMA is just a new way of deploying multiple agents with a single install. So think about it as just a new and improved installer. You're hearing many different the vendors talk about a single agent or universal agent, but basically you still have a number of different agents that collect data or probes that collect data from multiple sources. So that's what we're generally the focus we're going to provide on and the various different options for this. So when you think about this Universal Monitoring Agent, or UMA, currently it's for Kubernetes. We do have plans to support other platforms, but today it's for Kubernetes. So the whole idea here is that we're taking advantage of the Kubernetes technology and using containers to be able to bring them up and down, to scale them up, to connect, spin up other containers to monitor different areas. So this is basically auto discovery, auto monitoring, auto attach. And the auto attach is a new feature for applications for Java, so you don't have to restart. And then app infrastructure is we're deploying infrastructure type probes or agents to monitor. This is based on a new Kubernetes, right? It runs natively, and anywhere, generally these are the supported platforms that use Kubernetes that we've tested it on. Currently, there's a newer agent of this, 11.1.4, that's available today. But you just be aware if you're running with an APM 10 cluster, there's some configuration changes you've got to make the 11.1.4 agent so it's compatible. Just also a point note for your existing customers, there's a new doc site called Tech Docs, and it is under the 11 section of that Tech Docs. So when I mentioned about this, the UMA for Kubernetes, basically what we're doing is we're looking at the various layers in the Kubernetes environment. So at the bottom you got the OS, you got the Docker, then you've got in Kubernetes, and then you may have other collection type things. You may or may not have this environment. You see this more in dev environments, and we can leverage that if it exists. Also, you may encounter an area where your applications you're not allowed to make any changes, and if they enable JMX, then we can just connect them into the cluster, and you can monitor that as well as we get up into more to the application monitoring with the dynamic JVM instrumentation. So basically when you look at it, the way it's deployed is we're actually creating containers, and we're using basic as that of YAML, but we're actually using Helm, which is a Kubernetes utility, open source, that's available. So we provide Helm scripts that just allow you the Helm creates the YAML, and the YAML then runs in the Kubernetes environment. These are all Docker images that run on various nodes in the cluster, and then you can see it's fairly straightforward to actually run this. My one suggestion as we get into it, we're assuming you have access to the internet. If you don't, then you have to use some different commands to pull down the images, put them in your repository, then change your Helm or your YAML files, depending on which one you use, to point to your registry over the one that we're actually using. So if you look at this typical Kubernetes environment, this is a 4-node cluster, and each one of these represents a node. Okay? So these circles in here represents pods and applications running on it, so a containerized app. And then what you'll see here is the UMA App Container Monitor. So there's one of these on each node that monitors containers. So there's a process that gets started and it gets monitored. If you spin up a new node, then it'll spin up a new container for you automatically. It's built in the system. The administrator doesn't do anything. You also have some of these containers or pods that are actually collecting cluster information, service monitors, and service deployment. So these things are available as well, but these are just one per cluster. Okay, and they're the ones that some of them just gather information, some of them actually deploy probes and agents to gather the information. So when you're getting started, you start off with the Helm client, which generates the YAML file. And so you go down here and this is where if you want to install Helm, you can actually go and get it and install it, extract it. It talks about getting it set up and then using it, creating some namespaces. to get started with Helm. So it's fairly straightforward. More details when you get into it. Now, what I'm going to cover next is just the 4 use cases and how it actually works. And this is important in the things to consider when it deploys. This one is an application layer. This is, once you get to this is a JMX. So this assumes, let's say, the application layer, you're not going to be actually installing something. Application meaning like Java. We have Node.js and .NET coming, but today it's just Java. This looks at if you have JMX turned on, then you don't have to do anything with the container inside it, and you can just monitor it. This one also allows you to monitor at the container level of pod using things like Prometheus or just the APIs available, and that's these last 2. And then they'll just cover some brief troubleshooting steps. I'm going to touch on this slightly because it's more when you actually run into a problem. So first off, this is the application monitoring. This is injecting an agent. Now, if you're familiar with APM in the past, it required a restart. This does not require a restart. We're using what's called auto attach, which is an extension to auto attach. This is different than other vendors, and it uses a daemon set, which is a daemon set which means it gets deployed, and it's readily, and then as you add more nodes, it gets deployed to those environments. The concurrent versions are 11.1.4 is what I recommend. There's 11.1.3, but I would recommend 11.1.4. And if you're using 10.7 or if you're using our SaaS environment, just use the latest and greatest. You'll be better off. This bring your own. This is about modifying. This assumes up here that you're using out-of-the-box configurations, but if you have some custom PBDs and stuff, there's a step in there that allows you to incorporate that in to check which profile to use, and then use those. And then one of the nice things is about we set up the enable flags all at the Helm or YAML level. So it just simplifies, so you can do most of the work right there without having to get into anything else, which is a big step forward. So when we start on this, what's the first thing that happens? So we deploy it, we run the commands earlier we showed you, and what it's going to do is discover the environment. So that's the host in the container-based environment. So it's going to gather that information to determine which containers are running. Any containers that are running that are privileged, we're going to skip. So we're going to skip the privileged ones and then focus on it. So this is the next step. Get the containers, and the only ones that are non-privileged are we going to actually consider. Once we have that list, we compare that to your Helm and configuration if there's a white list or black list. In other words, is there ones we're supposed to pick the ones out of these that we're actually supposed to look at and monitor. Okay, and this talks about the configuration that you would do in order to select that down. Once we've got the list enabled, we check and see if the Java process is present. If it's that's like if one of your customers, the app owners, have actually instrumented with our Java agent and only our Java agent, then it will detect that and it'll skip over that, so you don't have to worry about it trying to install the agent again or auto attach. Then it says here it looks for these profiles. I mentioned you could have your own profile. It'll take one, it'll match and see if there's a custom profile that you want to add for each one, and it maps that out for you and applies the appropriate profile to that environment. Okay. Now this is all just the criteria. So when you're building your own, the way it works is basically it's this app server sets the pattern, directory, the profile, and all the information that's defined in the YAML file, right? It gathers that information from and deploys it based on the Java command line, and then the information is actually then copied over. So that's part of this process for using bring your own. It's other than using the default out-of-the-box configuration. So this allows you to extend the inventory of these different profiles that you can do for different environments. So like one could be for WAS, one could be Tomcat, specific to your organization, other than what's in the default. Okay. Once you've gone through that step, then the next step determines the free memory. So is it limited? If it's not limited. So these are your two choices in your settings. If it's limited, it checks to see if there's enough based on the limits you have set. If no limit, then we just check ourselves. We have some basic checking here that we check to make sure there's enough room to install the container. The last thing we want to do is install a container that's running it and put you over the edge. So that's It's just a safety measure that we built into the product when in the deployment process. Okay. And then the agent is copied and loaded into the environment, and it's auto-attached. And then it should. So this all happens fairly quickly. It usually takes a few minutes for when you run the UMA to get it deployed and configured, and then to show up in the GUI. Okay. So this is basically the information that's copied over in that step. All right. So it runs through these 7 steps in order to complete that, and that's just the application monitoring. For JMX Remote Monitoring, again, the assumption here is that each app has JMX turned on. Okay, and what it's doing is, this is configurable, but it's actually every 300 seconds, it's just connecting to the JMX ports that are open. Okay, and this is based on our APMI technologies, Kubernetes Remote Monitor extension, so that we can actually do that. And then this is configurable, the settings, again, through the Helm or YAML files that we provide. So how does it work? It basically, the pods exposes metrics. So here we're using the annotations feature to annotate it, to configure what's whitelisted, username, password, what's connections. But each application has to have the remote JMX turned on and enabled so that it's provided. Okay? And then we go through a similar process of determining what's blacklisted and whitelisted in order to gather the information. So in this case, in a pod, there's in a cluster, in this case 4-node cluster again, you'll have one of the daemons which will actually collect and listen to everything and all in the whole cluster, what's going on in broadcasting in that environment. It's basically more on the network ports that it's listening to for each application in that environment. Okay. Again, this is based on our APMI technology. The cluster information that we're getting it's doing the querying up here, and it's just updating this. This has no real intelligence to it. It's just running and gathering it. But this cluster info where you saw it deployed, this is the one that's actually gathering the information to configure the APMI. So it's leveraging that clustering information application that's running from our side. Okay. And then this is where the annotations of pods takes place. Okay. And then based on that, it configures. And what you should see is you will see this in our GUI, right? You pull up, this is our metric view, and it's based on the server, the process, and then the agent, and then you will see the JMX metrics appear under there. So right here, Kubernetes. Right, so they can gather all that information. So that's the JMX Remote. We did the Java before. Now the next one is container and pod level type information. So the way this works, there's 2 alternatives, Docker API, Prometheus. Prometheus we generally see more in the development environment than we do in the production environment. So in a development environment, the advantage is leverage the Prometheus that's already there. And what we're doing is just connecting to the Prometheus server that's running in the cluster and pulling data. If you don't have a Prometheus service, then basically we're using a Docker API to pull the metrics from the cluster into APM. Again, this is based on our APM IA, which is our APM infrastructure agent, and the OpenShift monitor extension. It is valid for both Kubernetes and OpenShift. And again, it's configurable through the Helm or YAML files to optimize or change the configuration for your environment. So again, we have the cluster deployment monitor and the app container monitor that we're actually here, and here's the nodes. So these are running. And then the way it works is, again, it's when it's deploying, it's detecting that JMX is on, right? Pulling the information in, and then it queries which data sets and which to monitor. And then this shows up here is how it shows up and organizes data. So one of the key things in this new UMA is also the correlation of the data in the ATC. So it's populating the ATC with key attributes so that you can look by pod, you can look by host, you can look by application. There's various different attributes you can actually use and leverage that this is actually does this. It gets stored into a data lake, which then if you are out-of-the-box dashboards don't work, you can actually use our DX DX dashboards to create custom top-end type dashboards or alerting as well. Okay. So this just gets into a little bit of the steps, and you can see here the ATC declaration via the API that I was just talking about. It decorates that information. And this is really key because in these complex environments, trying to look through just the hierarchical server, process, agent, Kubernetes, and stuff, kind of gets complicated. But if you look through the ATC, you can make a very simple view of what's going on with that in that environment. So what you can see here, this is just a graphical view. Here you're showing the OpenShift monitor, and you're showing the system edge, which is our host monitor. So that's the APMI host monitor that gets deployed. This is the OpenShift monitor, and then you get the Kubernetes high-level monitor, so more of a service-level monitoring that you can get information for. That's the way this stuff is displayed. The key thing is, though, you can actually look at the ATC and then get a better correlation of what's everything. It does all the correlation for you based on the container ID, the service it's in, the pod, and the host. You can use the correlations to correlate it and give you a better view of what's going on. Okay, just some things via privilege to get access to the Docker sock. So you just need some certain access to read and get everything in there. And so you need these key things here is the privilege to get to the Docker set daemon, and then the network in order to understand the networks deployed. And then requires service account, CAPM with read-only for the cluster role. So this allows you to access the APIs and get it. So just a couple things you need to make sure that you have. If you don't have these, then it won't work. You won't, because it's reaching out and it needs privileges in order to access that information. So what is Prometheus? It's just another open source monitoring and alerting toolkit. There's a process that's running in a container that gathers, and what we're doing is we're just connecting to the API and pulling that in. The key thing about it is time series collections, and it happens via pull model over the HTTP. Okay, and then there's a query language that we're leveraging in our agent to query that, to pull that data out of Prometheus. So it's really nice. It doesn't require any changes on the application. You just drop our UMA into the environment, it discovers it, and starts pulling the data in. So the application owners don't have to be aware of it. Node mine versus Prometheus. Pods exposed metrics must be defined with the following annotation. So here we're just setting up. You got to set this up in Prometheus to expose the data. And then Kubernetes remotely pulls the pod information. So it's just going through there. If it's set to true, it'll actually look. You can disable this, but this is actually going out and checking. That's that inventory process, utility process that runs to discover and then figure out if it should actually be instrumented or not. So here's the specs. Here's the nodes, the 4 nodes in our cluster, and here's the pods. And then here what you have is what we're running is in our containers, our pods. Right, here's basically the 3 process: cluster information, app container monitor, and the configuration Prometheus that runs. So the way this works is this thing runs first. It queries the API using the service count to discover all the various components that are actually in there. Once it has that, gets the annotations from the pods running, right, and from that environment. It pulls it from here in order to determine what to monitor. And then it filters the pods based on what's true and various other, if there's blacklists and whitelists to do, we go through that process as well. Then the metrics are matched via the data files from Prometheus, and then they're sent to the monitor, which then from APMI, it actually sends it over to APM. And then in APM, once they receive that, it actually shows up here. So here you can see the Prometheus model right here, showing up in here under Kubernetes, and it'll give you the metrics underneath it. So again, there's 2 ways we can actually pull this data: Prometheus or the API. Okay. Next, we'll just do in the clustering level. So here, the cluster monitoring via Prometheus is we're looking at the cluster, remote monitoring extensions, gathering the information, retrieving it. So we can gather both the pod information or the cluster information. There's 2 levels of information that takes place in the Kubernetes environment that we're monitoring. One is just the health and performance of the various cluster and the nodes in it, and the other one's the health and performance of the individual pods. And again, same thing, it's APMI we're leveraging, and then we're controlling what's enabled and what's blacklisted, whitelisted, is on or not via the Helm or YAML files. So you can, to see it work, you can look at what we covered earlier in use case number 3, on it, where it pulls, discovers, gets the information, maps the metrics, and then the APMI Prometheus agent will actually connect to Prometheus and pull the metrics based on all the previous configuration that has been taking place. And then here, the metric reporting via Prometheus at this level, on the cluster level. Down here you can see the Kubernetes and you can see the cluster name, and this will give us all the cluster, versus the other one which was based on the services or pods information for the various pods in it. And again, the best place to start is to go to the ATC, where the ACT correlates all this information across your organization and then allows you to drill down into the details if needed. Okay, so next, we've covered the 4 use cases: application, which is Java today, Node.js, .NET in the future. If you have applications have remote JNS enabled, you can just use the annotations to enable it so that you could send out a container that remotely listens and pulls a JMX without having to do the Java. And then for the container and pod information, we can pull that using Prometheus or the APIs. For cluster monitoring, we can also pull that in using the APIs as well. Okay, so just a couple things to be aware of. If you run into problems, one of the first things you want to do is just to make sure you followed all the steps and you see the containers and stuff and they're up and running. If they're up and running and you get it, is you can do the kubectl here, the pod name, and bash, and you can put it into debug mode. And this because you're doing this live on the container, it'll persist as long as the container stops and restarted, then it'll go away, but you can gather the information and help you identify where the problem is. You can also add a more persistent configuration to the deployment, which is then turning on debug. This is the Helm or the YAML files configuration. And then what you do is use the various kube commands, control commands, to see what's going on in the environment. So it's important to understand Kubernetes commands in the environment to see what's going on, to pull some data out of that environment. So one of the things that I said to check is to check the status of the pods, to get pods-n here, and then if you need to, you can restart the pods if needed to. So if you have a pod, one of the pods that's acting up, you can just go ahead and restart it. This just covers some of the basics of connecting in and how to get the versions. And one of the things I wanted to bring attention is just make sure you understand the versions of everything running, because there's been a lot of change in the technologies, and you just need to make sure the agents you're using match up with support the version of the software layers that you're actually using in the environment. Okay. And that covers it. If you have any questions, feel free to reach out to us. My name is Rob Gauthier. I'm part of the pre-sales organization, and I'm a customer success architect. Thank you very much.